Hi friends! This video is especially for beginners, as they are often faced with the problem of power source for their constructions. We will build a simple laboratory power supply with current limiting ability. The power supply will provide a stable output voltage from 0 to 15 volts and current of up to 1.5 amperes. In the project specifically used most common components. Anyone can easily find them. Now let's look at the scheme and understand how it works. It consists of three main parts. First is network step-down transformer to provide us the desired voltage. Simultaneously, it is for electrical isolation of the network. I used a transformer from power supply of the cassette recorder. You can use any other. The basic unit parameters will depend primarily on the transformer, though you need to consider one thing. The maximum output voltage of the power supply will be a few volts less than the voltage of the rectifier. The transformer is selected for the desired current. In my case, there are two windings of 20 volts. Current from each of them is about 0.7 amperes. Windings are connected in parallel. i.e., the total current is about 1.5 amperes. The second part is rectifier for rectifying the AC voltage to DC, and a capacitor for smoothing the voltage after the rectifier and filter noise. The third unit is a board of stabilizer. Let's examine it in detail. A circuit operates as follows. The constant voltage after the rectifier is supplied to the stabilizer circuit, which is stabilized to a certain level. Voltage stabilization will depend on the Zener diode that sets the maximum output voltage. In this case, it is 15 volts. But the problem is that such a simple current stabilizer is low, only about 15 to 20 milliamperes. This is why it needs to be amplified by a simple current amplifier built on the transistor VT1 and VT2. Transistors are connected in such a way to ensure the maximum gain. In fact, it is an analog of the composite transistor. The voltage regulator R1 performs the function of a simple voltage divider. It can be considered as two resistors connected in series with a tap from place of connection. By changing the resistance of each, we can adjust the voltage. This voltage is amplified by the earlier mentioned transistor cascade. The second variable resistor allows limiting the output current. If this function is not needed, then the circuit will look like this. As I said in the beginning, all the details are easy to find. All of them can be found in the old equipment. As the diode bridge, you can use ready-made bridges, which can be found in the computer's power supply or to collect from any four similar diodes with a current of 2 amperes. If you want more than 15 volts power supply, you must choose suitable transformer and replace the Zener to a higher voltage, for example, to 18 or 24 volts. Resistor R2 limits the current through the Zener diode. The calculation is based on the voltage of the rectifier. Resistor calculated so that the current through the Zener diode doesn't exceed a value of 25 to 30 milliamperes. If the half watt Zener used and 40-45 milliamperes, if the 1 watt Zener used. If you haven't suitable Zener, it is possible to connect in series 2 or more to obtain a desired voltage regulation. The regulator circuit operates in a linear mode, so the transistor VT2 will heat and requires a radiator. Now let's check the construction work. As you can see, the voltage is continuously adjustable from 0 to 15 volts. Now check the current limit function. Without load, if we rotate the regulator, voltage almost did not change. This indicates that the operation of the limit function is correct. The current is infinitely adjustable from 180 milliamperes. Maximum output current in my case is about 1.5 amperes. This is quite enough for the average needs of the majority of radio amateurs. Despite the simplicity of design, if output current is around 1 ampere, we can see the drawdown of the output voltage is less than 0.2 volts, which is very good for this class of stabilizers. The power supply circuit can tolerate a short circuit duration less than 5 seconds. In this mode, current is limited to 1.7 amperes. Montage can be done without PCB, but design on the printed circuit board looks more beautiful, especially since I drew it for you. Indicators could be analog pointer instruments or digital units. A box may be from the computer power supply or any other convenient housing. I think this is pretty fit option as the first laboratory power supply unit. Under the video you will find an archive of the project, links to buy components and ready-made power supplies. Thanks for watching. If you like it, please share with friends. With you was Aka Kasyan.